Today we're going to be learning section 1.2 on estimation, graphs, and mathematical models, So we're going to start with estimation, which really has a lot to do with rounding. Estimation is the process of arriving at an approximate answer to a question. For instance, we may estimate that it takes us half an hour to get home from work when it actually takes 24 minutes exactly, or something like that. Estimation can be very helpful in mathematics as well to check our answers and to see if they make sense. So estimation is really twofold. First, it allows us to approximate our answers, usually rather quickly, so we can often do the math in our head. But second, it gives us, again, an easy way to see if our actual answers are in the ballpark and if they make sense. So estimation is a really great tool. Excuse me. I know I use it a lot, particularly when I go shopping. So if I'm going grocery shopping and I'm trying to stay more on a budget, or maybe I'm paying with cash that day instead of relying on my debit card or something like that, I'm going to be definitely estimating how much I think my bill is going to be so that I make sure I have enough money, right? Or if I'm shopping and I see that something is maybe 20% off, then I can estimate that amount in my head and then have an idea of what that final price would be for that item and do I really want to spend that amount or not. So estimation, again, gives us a kind of a quick way just to get a ballpark answer to see if our technology steps or if our calculations make sense, or also to kind of just give us a rough estimate if we need to make a quick decision. So to estimate, we do need to know how to round. Right? Estimating is basically just a rounding tool. It's a way to round. So the numbers we use for counting 1, 2, 3, 4, 5, 6, 7, and so on are called our natural numbers, right? Think about nature. We learn them when we're little. And when we add the value 0 there with the natural numbers, we obtain what are called the whole numbers. So your whole numbers are the numbers 0, 1, 2, 3, 4, 5, 6, 7, and so on. We're not talking about integers right now, so we're not doing negative numbers. In this case, we're just talking about our positives and our 0. And then the numbers specifically 0, 1, 2, 3, 4, 5, 6, 7, and 9, 8, and 9 are called digits. And digits are used to write all of our numbers, right? So we combine these in different ways to express our numbers. And here is a place value chart. Okay, so this, another one in your book looks a little bit different, but it's the same idea. So you have your place value chart here. These are just the whole numbers, so we're not looking at decimals just yet. So you start with the ones place, then the tens, the hundreds, the thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions, and so on. So each of those digits has their own place value. Notice when we're talking about whole numbers, not the decimal side, all of our words end in usually NS or DS. So we don't end in a TH. We'll see in a sec. When you end in a TH, like if I say hundredths, then that refers to the decimals. So if I say hundreds, then I'm talking about the whole number side. So let's practice some of our rounding. And again, you should be familiar with this, so feel free to kind of go through these examples and check your answers and see if you're getting them right. If you feel confident, you can move on. But we are going to review rounding because it is an important skill. So rounding gives us an approximate answer rather than an exact answer. And we do the following. So what I like to do is I like to physically underline the place value to which we're rounding. And then I look at the value, the digit to the right of that underlined value. And the digit to the right of the underlined digit is called the critical digit. If that critical digit is a 5, 6, 7, 8, or 9, we add 1 to the underlined digit. And if the critical digit is small, 0, 1, 2, 3, or 4, we just leave that underlined digit alone. And then we replace all digits to the right with zeros. Usually we say things like round up and round down, although technically when we round down, we actually don't round anything down. We just kind of leave it as it is. So just be careful about those expressions if you're used to them. All right, so let's take the world population, which is this value right here, and round it as follows. Now, if you're pretty good at your place values, you can go ahead and jump right in. If you're struggling though, what you can do is use a place value chart, and I left some room here. You can put that number right in here so you can line up your place values a little bit easier. So I do recommend doing that if you're having a little trouble getting started or if the numbers are really large and you're not used to some of the place values yet. When I add it in, I'm going to start on the right. So here's the 6, the 5, 0, 2, 4, 2, 6, 7, 4, and 7. Okay, so that way I can see my place values a little bit better. So I'm going to round to the nearest 100 million. So I'm just going to rewrite the number down here so I can do each example. And I'm going to underline the 100 million place value. So whatever that digit is. So if I need to, I can go back up here and say, okay, well, where's the 100 millions? And it's right here. It's at that 4. So I'm going to underline that 4. So that's going to be my last value. Everything else to the right of that is going to become a 0. I just need to know, do I leave the 4 as it is, or do I make it a 5? Those are the only two options that are going to happen. And to do that, you're going to look at this next number. So because this number is a 7, so it's in the group 5, 6, 7, 8, or 9, right? Say it's like a big number. It's going to round us up. So we're going to add 1 to that 4. So what our final answer is going to be then is going to be 7. 4 becomes a 5, and then I have 1, 2, 3, 4, 5, 6, 7, 8 zeros afterwards. So it's about 7 billion 500 million, right? Rounded. So let's do the same thing again. Let's round this time to the nearest million. So I'm just going to rewrite that starting number. Sometimes when numbers are so big like this, even I have a hard time doing the rounding in my head because there's so many digits. So it does help to write it and underline where you're focusing. So I need the millions place, and that would be this 6 right here. So this one, that's the millions place. So I look to my value to the right. Now that number is a 2. And if I look, it falls into the first category of 0, 1, 2, 3, and 4. So it's a small number. When we have a small number, we are going to just stay. So it's technically called rounding down, but really we're staying. That 6 is going to stay alone. So this is going to become 7, 4, 7, 6. Okay, so it stays. And then I have 1, 2, 3, 4, 5, 6 zeros. So 7,476,000,000. Okay. I like circling that number to the right as well because it kind of reminds me where those zeros start. It looks like a 0, right? So it's a good reminder. All right, and then one last time, we're going to round to the 100,000. 100,000 place. So if I need to, I can go back up here. Where are the 100,000s? And I can see that they're right here. So that is the number 2. It's this number 2. And again, I'm going to look to that number to the right. So my number here is 4. It's in the group 0, 1, 2, 3, 4. It's a small number. So we're going to stay. That 2 is just going to get left alone. And then everything else to the right will become a 0. So 7,476,200,000. I'm going to do a little bit more rounding. So some of you are probably familiar with the number pi. We use this symbol here to represent the number pi. It actually occurs a lot, particularly in geometry formulas. And the first 7 digits are given by here. It actually goes on forever. It's an irrational number without a pattern. But these are the first 7 digits. And so now we're going to take it to kind of the next step and see how I had that TH here. So let's talk a little bit about what happens after the decimal. So let me go back over here. I'm going to add this in now. So here would be your decimal point. Okay, so the decimal point's coming in here. So the next few places are most common. What you're going to have next would be the tens place. Then you're going to have the hundredths place. Then you're going to have the thousands place. And those tend to be the most common of the decimal places. You can go further. So next would be the 10,000ths, 100,000ths. It mimics this right here. So it mimics the same ordering, but with a TH at the end. So you're going to see that when you're talking about after the decimal, you're going to see that TH. Now, the only thing we don't have is we don't have like a ones place. So you have the ones, and then after the decimal, we start tenths, hundredths, thousands, 10,000s, and so on. So here, we're going to round to first the hundredths place. So I have 3.141592. So the hundredths place is 2 places out. That's right here. And then I look to my number to the right. That's a 1. It's in that small category. So small means stay. So this is going to become 3.140000. Now, when we're dealing with decimals, if it's after the decimal point on the end, we actually don't need all these extra zeros. So when it's before the decimal, you do need them, right? Because they're holding those place values. But after a decimal, extra zeros on the end are just extra zeros. So you can drop them and just use 3.14. Here we're going to round to the thousands place. So thousands would be the third number out. And I look at the next value. This is a 5. It's in the category of 5, 6, 7, 8, or 9. That's the big group. So what you do is you add 1. We're going to round up. So this is going to become 3.14, and then this becomes a 2, 0, 0, 0. But again, we don't need those remaining zeros after the decimal point. So when you're rounding, another way to keep in mind your decimal place for after the decimal point is how many zeros there are. So if you think about hundredth, 100 would have 2 zeros, so you're 2 places to the right. 1,000th would have 3 zeros, so you're 3 places to the right. So when you're talking after the decimal point, you have, like I said, you have that tens place first, then you have your hundredths, then you have your thousands, then you would have your 10,000ths, your 100,000ths, and so on. Okay, so those would be your place values on the right after the decimal. You purchase bread for $2.59, detergent for $5.17, a sandwich for $3.65, an apple for 47 cents, and coffee for $8.79. The bill was given to you as $24.67. Is this amount reasonable? So we're not asking you to recalculate the exact amount here. We're kind of saying, does this make sense? So does this amount seem reasonable? Now, when you're estimating, you really can round however you want. So sometimes the problem will be very specific and tell you how to round. But in the real world, it's up to you. So for money, I usually tend to round to the nearest dollar. Just makes it easier. But I suppose you can round to the nearest half dollar as well. So a lot of times for money, we're just going to round to the nearest whole dollar. Okay. Now, when you're rounding to the nearest whole, that is the ones place. Okay. So I'm going to take each of these items. So I have the 259 for bread, the 517 for laundry detergent, the 365 for the sandwich, the 47 cents for the apple, and the 8.79 for the coffee. And I'm going to round to the nearest whole. So that's the one place. I'm going to round to this place value right here. So I'm going to look to the value to the right. Here I see that 5. That 5 is in the big category, so I'm going to end up bumping this up. So this is about $3. Here, my next value is a 1. This is small, so I'm just going to put a little arrow to make it to note that it's small. So that 5 is going to stay. So this is about $5. Here, that next value is a 6, which is large. It's in that big category. So we're going to bump this up to about $4. Now here, my next value is a 4. This is actually in the small category, so we would stay. That 0 is actually going to stay. I know it looks a little bit weird, but we're rounding to the nearest whole, so that would round down to 0. And then for $8.79, that 7 is big, so this is going to round up to about $9. So let's see what we get here. We have 9 plus 0 is 9, plus 4 gives me 13, plus 5 gives me 18, plus 3 gives me 21. So our estimate is about $21. So I would say that actually the 24.67 probably seems too high. So I would actually maybe go in and check my receipt and see what happened. Now there could be an explanation for it. Maybe a lot of your items have tax. In Massachusetts, we don't have tax on food items. Restaurants are not included, so it's food items from grocery stores and things. But we do have tax on things like detergent or paper plates or things like that. Here, it doesn't seem like there would be enough tax to make up, almost $4. So this is one where I would say that looks a little bit too high. Maybe we should go back and double check our account or the bill. And actually, if you redo the addition, you'll see that the real sum is actually only $20.67. So there must have been an error somewhere in the calculation. Okay, let's do another example here with estimating, and then we'll look at some examples estimating with graphs. So here, a carpenter who works full-time earns $28 per hour. Estimate the carpenter's weekly salary. Now, we are making some assumptions here. So full-time is usually 40 hours per week. I know that could be different in some industries, but full-time is usually 40 hours per week for most people. So we're going to make that assumption. And I'm estimating. So I don't need the exact answer. If I was looking for the exact answer, I would take that $28 and multiply it by 40. But I'm not. I'm estimating. So if I'm estimating, I want to make my life easy. So that $28 is very close to $30, right? If we round to the nearest tens place, so here, I'm going to say that 8 is big. It's going to end up bumping that 2 up to 3. So he makes about $30 an hour. And then 30 times 40 hours per week. Well, 3 times 4 is 12, and then I have the 2 zeros. So he makes about $1,200 per week. Now, think about this as well. Notice that we estimate it and we round it up. So if this is an approximation, this is not exact, he actually only makes $28, so he actually would make less than this. So just kind of keep that in mind as you're estimating, where we had to round up here. And $2 is kind of a lot, right? $2 times 40 hours a week, that's $80. So it's about $100. We're off. It's going to be a little high, but that's going to give you a rough estimate. Now for B here, we want to estimate his annual salary. So that means for the whole year. Now we know his weekly salary. Now annually, there are 52 weeks in a year. So I could do 52 times the 1,200, right? But I'm trying to estimate. I'm trying to do this in my head to make this fast. So what we can do is, again, round. So this is about 50 weeks, just to make it easier, right? So if I round to the nearest 10, that 2 is small. So it's going to keep this as a 5. So it's about 50 weeks. So we could do 50 weeks times that 1,200. Now, 5 times 12 is 60, and then I have 1, 2, 3 zeros. So we can estimate that he makes about $60,000 a year. And again, these are estimations. We could always find the exact amount, by taking out a calculator or doing some work by hand, but estimating is supposed to be a kind of a quick, easy way for us to figure that out. So we have some estimates about what you can expect or what this carpenter can expect for his salary.